All right, in 12.1, we're going to talk about rationalizing with conjugates. Now, rationalizing is what we do to remove radicals from the denominator. Now, what's different today is that our denominators are not just going to be one radical, but they're going to be binomials, two terms with radicals. So I want you to think back to what we did with complex numbers. Very, very similar. We did complex conjugates. Remember how we had a real portion and an imaginary portion of the number, and we changed the sign? And the whole purpose of that was to get rid of the imaginary part of the denominator, right? Well, it's going to be the same exact idea, but instead of imaginary portion, we're going to have radical portions. So we're going to be changing the sign, like we did before, between them to get rid of them when we multiply by the denominator's conjugate. All right, let's look at today's notes, and we'll get you going. All right, so this part here is just review. Let's look at this. 2 plus square root of 7 times 1 plus 3 square roots of 7. So let's just multiply those out. Let's do FOIL. When we FOIL this, we will get, first terms, I'll get a 2. Outer terms, I'll get a 6 square roots of 7. Inners, I get 1 square root of 7. And last, I'll get 3, and then 7 times 7, right? That means the 7 is going to pop out. So as I clean this up, 2, putting these two together, plus 7 square roots of 7, and that's going to be 7 times that 3, so plus 21. So my final answer will be 23 plus 7 square roots of 7. Okay, on number 2, I want to first realize that this 18 under the radical is not reduced. So that 18 is really 9 times 2, right? Well, 9's a perfect square, and that means a 3 can come out. So I can rewrite this as 2 minus 3 square roots of 2 times 3 plus, again, it's the same radical, 3 square roots of 2. So as I do this, I'm going to do FOIL again, right? So first terms will be 6. Outer terms will be 6 square roots of 2. Inner terms will be 9 square roots of 2. Last terms will be negative 9 square root of 2 times 2, so that 2 is going to pop out. So I'll have 6 minus 3 square roots of 2, and then this will be negative 18. So when I combine like terms, I'll have negative 12 minus 3 square roots of 2. Now finally, look at number 3. This one is a conjugate. Notice that the terms are the same, but the signs are different. This is the multiplying it by its conjugate. So I want you to see what happens. When I multiply first terms, I get 9. Outers, I get negative 3 square roots of 2. Inners, positive 3 square roots of 2. And last will be square root of 2 times square root of 2, which is 2. All right, so look, my middle terms go away. They cancel out, and I'll have 9 minus 2, which gives me 7. So problems like this one, like number 3 here, are what we call conjugates. And they look like the difference of squares. The purpose is they remove all the radicals. So if the denominator is a binomial, meaning two terms, you will have to use its conjugate to rationalize the denominator. So let's try this out. Look at number 4. I have a binomial in the denominator, and one of them has a radical. So I need to multiply by its conjugate. So I'm going to figure out what is its conjugate. So 7 square root of 6 stay the same, but I had to put a minus. So remember, it's just a funny looking 1. This time it's binomials. It's still equivalent to 1, and there we go. Now let's do this. Let's just distribute that 9 here, and we'll have 63 minus 9 square roots of 6 on the top. On the bottom, first terms, we'll have 49 minus 7 square roots of 6 plus 7 square roots of 6. And then square root of 6 times square root of 6 is going to give me a 6, so it's going to be minus 6. So as I clean this up, I'll have 63 minus 9 square roots of 6 over. These two terms will cancel out, and I'll have 49 minus 6, which gives me 43. Let's look at number 5. There's a binomial here, so I need to figure out its conjugate. 8 plus square root of 6. What I do to the top, I have to do to the bottom, so it's equivalent to 1. Now if I distribute, here we go. We'll have 40 plus 5 square roots of 6. On the bottom, I'll have FOIL, I do 64 plus 8 square roots of 6 minus 8 square roots of 6 minus square root of 36, which is 6. These go away. And then I'll have 40 plus 5 square roots of 6 over 64 minus 6, which is 58. Now, I can look at this and go, oh, look, I can take a GCF out of the top, right? I can take a 5 out of those two terms and reduce it a little bit, maybe. So if I do that, I'll have 8 plus the square root of 6 over 58. But if you notice, this does me no good. I can't divide 58 by 8, so that does me no good. So if you've realized that you've done all that work and it doesn't do you good, then don't leave it here. Leave your answer here if it doesn't reduce. All right? Now, what if it does? To reduce, you're going to pull out a GCF first and then cancel it from the front. So when you pull out a GCF, then you can cancel from the front. This is the only way you can cancel. Okay, it's the only canceling allowed. Let me show you why here, okay, as we do this. So let's look at number 6. So what I noticed first is the square root of 4 it can be simplified, right? It's the square root of 7 minus 2. I should simplify that first, make my life easier for sure. So then I'll find the conjugate of that. It would be the square root of 7 plus 2. Same on top as bottom. Then I start distributing. Now this is one term, so I'm just distributing. So this would be negative 3. 5 times 7 is 35, so square root of 35. Negative 3 times positive 2 is negative 6, and it would be square roots of 5. Now, the bottom, square root of 7 times square root of 7 gives me 7. The inners, 2 square roots of 7 minus 2 square roots of 7 minus 4. All right, middle terms cancel out. Let's clean up the top here. We'll have negative 3 square roots of 35 minus 6 square roots of 5. All of that, 7 minus 4 is 3. Now, hopefully you see that there is a GCF of 3 that can come out of this, right? Now notice I want to take out a positive 3. I don't want to take out a negative 3. So think ahead before you just start doing it really quick. I want to take out the positive 3 to get rid of this one. So if I do that, if I factor out a positive 3, that's going to leave me with a negative 1 right there. I don't have to write that, but I could. Square root of 35 minus 2 square roots of 5. All of that over 3. Now I can see that these things cancel out. Again, this is the only way we can cancel. So then my final answer is just negative square roots of 35 minus 2 square roots of 5. So simplified quite a bit. Let's look at number 4. So I look first, is everything simplified in the denominator? Yes, it is. So I can just directly go to my conjugate. So I get square root of 3 plus the square root of 5. And I start distributing on the top. So I will have 4 square roots of 21 plus 4 square roots of 35. All right, on the bottom, I'm going to have square root of 3 times square root of 3. Well, that's 3. And because I know they're conjugates, I know the middle terms are going to fall out. It's going to be minus square root of 5 times square root of 5 was just 5. So now I can go to 4 square roots of 21 plus 4 square roots of 35 minus 2. Now, again, let's do GCF here. I want to get rid of that negative 2. So if I factor out a negative 2 in the top to get rid of this negative 2 in the bottom, what's left over? Well, 4 divided by negative 2 is negative 2 square roots of 21 minus another 4 divided by square root of 2 is going to give me a negative 2 square roots of 35. Okay, now these negative 2's cancel out, and my answer is negative 2 square roots of 21 minus 2 square roots of 35. All right. Let's look at this last one. All right, this one has cube roots. All right, so let's remember what we did with cube roots. We want to get rid of radicals, right? So we have to multiply by a cube root that's going to make, when I multiply this times this, the radical go away. That means if it's cube root, I need 3 of them, right? Well, there's 1. Let's put 2 more in there. All right, it's just a funny looking one. Now I'm going to distribute. Okay, I'm going to distribute. So think of it like this way, right? Kind of distributing backwards, but we're still distributing nonetheless. All right, so as I do this, I'm going to have 2 cube roots of x squared plus cube root of x times cube root of x squared is going to give me an x. That x is going to pop out because there'll be 3 of them, right? On the bottom, this is going to give me just an x because it'll be the cube root of x cubed, which just cancels out. Now, resist the urge to cancel this guy. You can't do that, okay? You can't do that. That's a no-no. If there is no GCF, there is no canceling, okay? So make yourself a little note here. If there is no GCF, there is no reducing. Be really careful about that. You want to resist that temptation. And here's the reasoning. This x right here is attached to this first term with that plus sign. You can't cancel parts, all right? Hope this makes some sense, and we will see you in class, and let me know what questions you have.